So this is a direct online motor starter, and let's check what is made up of a direct online motor starter. The direct online motor starter is basically made up of a contactor. This is a contactor, and it's made up of an overload, and then we have some switch here, okay, some start switch, okay, which is actually a push button. Also notice that the contactor, okay, is made up of a coil. You see, A1, A2 is actually a coil. It's a coil. Now, the direct online starter is made up of two circuits. We have a power circuit and we have a control circuit. The power circuit, okay, it basically supplies, okay, it is the main supply of the motor. It is the circuit that provides the motor with the power that enables it to do what? To run. So how do you connect the power circuit? On this contactor we have L1, L2, L3. So you connect your three phases here, okay? One phase here, another one here, and another one here. So if you can see the yellow, the blue, and the brown cables have actually been terminated at L1, L2, and L3. And then at the terminals T1, T2, and T3 of the contactor, that is where you connect, okay, the terminals of the overload. This is the overload, and then after you've done the connection down there, okay, at the overload we have three other terminals. We have this one, and this one. That is where you connect the cables that now supply the motor. So that is the power circuit. That is the power circuit. And one thing you need to notice is that this contactor is the L1 T1, L2 T2, and L3 T3. And of course we have the extra contact NO, which is normally open. 13, 14 are actually normally open. So for the motor to be supplied by power, the contactor has to be closed, okay, so that when it is closed now, there will be power flow from L1 down to the supply point. So that's the power circuit. And what is a control circuit, and what is the purpose of a control circuit in a DOL starter, a direct online starter? The purpose of a control circuit is actually to start and to stop the motor. So whenever you want to start the motor, if you look at this casing, we have the green button for starting and the red button for stopping. If you want to start and to stop the motor, you have to use the control circuit. So the control circuit basically controls the power circuit. And how is its connection done? But I would wish to say that the basic aspect or the basic theory behind operation of a contactor is that when this coil, which is labeled A1, A2, is energized, okay, it will form a magnet, and this magnet will bring about closing of the contacts of the contactor. And when they are closed, there will be flow of there is going to be flow of power. So if you can look at the casing, we have 415 to 440, and then we have 50 Hz, then we have 440 to 465 volts, and then 60 Hz. So these are the specifications of the coil. They tell you the kind of coil that we have here, whether it is a coil that is going to be supplied by a single phase or it's a coil that is going to be supplied by two phases. Whenever we have 220 to 240 volts, then 50 Hz, it means that that coil is going to be supplied by a single phase. For this one, which is labeled 415 to 440, it means that it's going to be supplied by two phases. That means that one end of the coil A1 is going to be supplied by one phase, and then the other end of the coil A2 is going to be supplied by another phase. So if you can look at this one, there is a red cable here, this one, the small one, it has directly gone to A1. It is supplying one of the ends of the coil. And then for A2, for you to connect A2, of course, if you know you connect A2 directly from one of the faces, the contactor will automatically begin working, but it will not be controlled. So for us to control this contactor so that when you switch on, it goes on, and then when you switch off, it goes off, you take one of the supplies here, that is one of the faces. You can use this one or this one. So for this one, we've decided to use this one, L3, and then from L3, this cable has gone down to the overload. Okay, it has gone to 95 and 96, which is the normally closed contact of the overload, and then from there it has gone to the start switch. Okay, then from the start switch it has gone to the normally open contact. Okay, the normally open contact, right? And then notice that there is another supply, or rather there is a connection from NO to down here where we have the start switch, and then we have another connection now from here to A2. So what is going to happen? Also, what basically this one means is there is a supply from one of the faces. It has gone to 95, 96, which is the overload. Then it has gone to the start switch. Then it has moved from there. It has gone to the A2, okay, which is the other side of the coil. And then there is a parallel connection of this start switch. Okay, it has been connected to the normally open. So there's a cable moving from here, the upper side of the start switch, to the normally open, and then there is a cable that ought to move from the 14 normally open to the switch. So what basically happens is when you want to start the motor, you put on. When you put on, there is going to be flow of power from L3 to 95 and then to 96. This one is normally closed, and then it goes here. It will start the contactor, and then after it has started the contactor, remember when you remove your hand, we expect power to be cut here because this is a push switch. So what keeps this contactor, okay, intact, not to be off until you press the stop switch, is actually this connection on the auxiliary contact 13, 14, which is normally open. So